putting up important topics that we would like to emphasize, discuss, and have presented in a good way. We also have these meetings open so that everybody can attend this. So since 2022, we're also collaborating with Academia Europea on these series. And also from this year, we have the Selskap for Vitenskapens Fremme. So this is a joint collaboration between the three organizations. And I'm very happy that we are gathered here today. And I'm so happy to see so many in the audience because there is a beautiful weather outside, and there is one ocean week that has hosting many other meetings and lectures. So I'm happy that you are found the way to Student Center today. And we're super excited and glad that we have Lisa Levin with us, and we felt that it was too bad not to take the benefit or advantage that she is here, and she is attending 3 other conferences, so she also managed to squeeze in this lecture here today. So I just want to inform everybody in the audience that this lecture will be recorded, so if you have any problems, the camera is in the back of the audience and everything will be recorded so that you know about that. And with that, I will give the word to Anne-Gro V. Salvanes to introduce Lisa for the lecture today.
Thank you. We are so pleased that you would like to join us here, Lisa, for this talk about deep seabed mining and how the science about that meets policy and also how conservation matters of the deep sea animals. But first, then a little bit about you. Lisa Levin, she is a distinguished professor of biological oceanography, emerita, at the Scripps Institution of Oceanography at the University of California, San Diego. And she is passionate about the deep sea and researches the ecology of different ecosystems on deep continental margins, their vulnerability to climate change, and to human resource extractions. And here in Bergen, she is also involved in research on the deep sea ecosystem on the West Norwegian fjords, which we are very pleased to have you here on that. And she also serves on she is a scientific co-lead for both the Deep Ocean Stewardship Initiative and the Deep Ocean Observing Strategy. And over the last 40 years, she has been out at sea on many expeditions, over 50 expeditions to the Pacific, to the Indian and the Atlantic Oceans, and also even to Norwegian fjords around Bergen. And she has both collected animals and observed animals from the deep sea in the submarines, which impresses very much. So, now the floor is yours.
Thank you. I can put this down and turn on my microphone, right? Okay, can everybody hear me okay? Yeah. Well, it's my pleasure to be here to talk to you all today about deep seabed mining and biodiversity conservation. So I'm going to start with a question for the audience. How many of you feel you have no familiarity with the subject of deep seabed mining? Raise your hand. Okay, good. None. Yeah, really very little to none. And that looked like at least half the audience. How about a little bit of familiarity? Okay, that's most of the rest of the audience, and there's a few people I know who know a lot. Okay, but that gives me a good starting point. What I'd like to do is talk about a series of things sort of leading you into the subject, and I'll start at the beginning, explaining the discovery of deep sea biodiversity and the discovery of minerals associated with that. I'll talk about why people want to do deep seabed mining, I'll talk about what ecosystems they want to mine and their vulnerabilities. Then a little bit about how the governance of deep seabed mining, and this is where we get to the policy part of this talk. I'll talk about how it's managed and how environmental impacts are managed, and then I'll sort of close with information about the current state of seabed mining and what some of the information gaps are and where I think people are going or where we might be going with this. Okay, but I'm going to start with some deep ocean basics. As a deep sea scientist or biologist, we refer to the deep ocean as anything below 200 meters, and that means it's most of the ocean. And in fact, not only is most of the ocean deep, but most of the ocean lies in international waters, about 2/3 of it, in fact, just under 2/3. But if you look at the habitable volume on this planet where life can exist, over 95% of it is the deep sea. And that is simply because the ocean is so deep. The average depth of the ocean is it should say 3,800 meters, not 3,800 kilometers. So it's not that deep. But the deepest part's 10,890 meters or so. So 3.8 kilometers is average, and so half of it's even deeper than that. So if we go back to the evolution of what we know about the deep ocean, we can go back, hundreds of years. If we go back 1,000 years or, hundreds of years, when people were on the ocean, they believed it was full of sea monsters, and so depicted up here is the Norse kraken in various forms. The sailors were afraid of the deep ocean, but they did think there was something alive down there. It just happened to be giant monsters, right? We began to explore the deep ocean seriously in the 1800s, and there were expeditions. The most famous of these is the Challenger expedition in the 1870s. So a lot of ships went out and dropped things over the side to sample and measure the deep ocean. And the picture that emerged from the first 100 years was a deep ocean that was cold, dark, salty. We knew it had a lot of high pressure. People thought it was pretty much muddy on the bottom, that it was very homogeneous and stable and very quiet, and food limited. In other words, people thought it was basically a desert with little to no life there in that first 100 years of exploration. And then somewhere around the 1950s and 60s, people began to develop all sorts of advanced technology for studying the ocean. And we developed, let's see if I can point to some of these. It's a little bit high up there. Multi-beam sonar for mapping the deep sea and in pretty high resolution. We developed acoustic tools that could detect bubbles coming out of the seafloor at methane seeps, for example. We could detect plankton migrating up and down every day into the deep sea. We developed submarines. This is the Alvin, which I've had the pleasure of diving on many times, to take us down, to look out the window and observe the deep sea and take samples. We have remotely operated vehicles and towed camera sleds and autonomous underwater vehicles now that produce imagery of the seafloor and all sorts of other sensors that people have developed. So, really the last, 60 years or so, we've had a revolution in our understanding of the deep sea. And we've come to realize it's not that flat, desert-like, mud-covered bottom out there. We've found all different types of ecosystems, and each of those ecosystems has had its own associated biodiversity, species that live only in those ecosystems. So we've discovered massive areas of low oxygen, ribbons of low oxygen along our continental margins. We call these oxygen minimum zones. We've discovered abyssal plains beneath the least productive parts of the ocean, and they are covered with these potato-sized nodules. We've discovered that there are literally tens of thousands of underwater volcanoes called seamounts, and they have dense aggregations of filter-feeding animals. We've discovered that there are literally thousands of canyons and fjords, fjords at high latitudes, canyons all over the margins, and they also support dense assemblages of filter feeders. We've discovered that there are massive reefs or gardens of corals and sponges that create habitat themselves and promote biodiversity for other organisms. We've discovered chemosynthetic ecosystems, the methane seeps and hydrothermal vents, where the animals rely on chemical energy rather than photosynthesis and sunlight, and they feed on bacteria, either as symbionts or as free-living forms. Probably the least known of the deep ocean realms is the deep pelagic, the water column, where most of the life has yet to be described, but there are all different life forms there. And we've discovered, that there are massive migrations of mesopelagic organisms, including small fishes that form the largest migrations on the planet, up and down, billions up and down every single day. So we have this amazing set of ecosystems that hosts a very high biodiversity. And I just want to take a few minutes to talk about why this could be important to us. This becomes relevant for seabed mining. This biodiversity underpins the cycling of nutrients, the remineralization of organic matter that produces nutrients that make their way back up to the surface, that fuels the phytoplankton, that fuels the zooplankton, that fuel the fish, that fuel our fisheries, and we rely very much on that primary production. This biodiversity contributes to the deposition of carbon dioxide from removing it from the atmosphere to down through the water column to the seafloor. This biodiversity helps remove and detoxify waste. It's now thought to be solutions to some of our really wicked problems. There are all sorts of natural products and enzymes that produce medicines, different kinds of pharmaceuticals that might be antibiotics or anti-inflammatory agents that people are looking at. There are new sources of food down there. Of course, we've been extracting oil and gas from the deep sea, and that oil and gas is actually all the dead organisms that have accumulated down there. There are new kinds of technologies, new industrial agents, biomimicry, lots of different ways that people are thinking deep sea biodiversity can help out humans. But of course, I think the most important aspect is that it keeps the planet healthy. It contributes massively to the carbon cycle and to nutrient nitrogen cycle, and we need this biodiversity. So at the same time that we discovered all of this heterogeneity and biodiversity, we discovered that this biodiversity is associated with minerals. So, for example, we discovered our low oxygen zones have phosphorite. The bacteria there sequester phosphorus and produce phosphorites, which people are interested in mining for fertilizers. We've found that the polymetallic nodules on the abyssal plains are full of copper and zinc, cobalt and nickel, which we are interested in for green energy purposes, and I'll come back to this. We've discovered that the seamounts have ferromanganese crusts accumulating, also rich in cobalt, nickel, molybdenum, and cerium. We've discovered that at hydrothermal vents, the hot waters emerging from the crust precipitate out massive sulfides that are rich in copper and zinc, lead, silver, and gold, and there's interest in mining these. We found that the canyons accumulate organic matter. They're full of oil and gas that we are busy extracting. We found that fish aggregate around seamounts, and we harvest these. For example, the orange roughy in the picture up there. We found that Chilean sea bass aggregate around methane seeps, and those are harvested in some parts of the world. And that the cold water sponge reefs and coral reefs provide juvenile habitat for fishes, like rockfishes that we harvest. And then there's now even interest in harvesting the mesopelagic fish in some places that migrate up and down. So we have all these resources, including mineral resources, associated with this biodiversity that we've discovered. And these minerals literally are spread globally around the world. So you can see the polymetallic sulfides along linear features. These are the mid-ocean ridges in most cases. In the different oceans, you can see the polymetallic nodules beneath the less productive parts of the ocean. Those are the red blobs. And you can see cobalt-rich crusts, usually associated with seamount chains. And those are the green blobs on this map. But I just want to give you a feel for how widespread these resources are. And Norway has them too. So Norway has massive sulfides with lots of copper and zinc. And some of these have been found in the last 10 to 20 years associated with hydrothermal vents. Norway also has ferromanganese crusts. I believe these are in the Norwegian Greenland Sea, again with lots of magnesium, cobalt, cerium, and rare earth elements. So Norway has a Seabed Minerals Act under the jurisdiction of the Norwegian Petroleum Directorate, and this act facilitates exploration for and extraction of mineral deposits on the continental shelf in accordance with societal objectives, and there's a number of them you can see listed here, including the environment and safety and value creation. So why do people want to mine these minerals that I've been talking about? Well, there is a rising global demand for the metals, and in particular, these metals are used to make the batteries in both, this should say electric cars, not just hybrid car batteries, but definitely electric car batteries. Some of the elements are used in wind turbines and solar cells and all our electronics, our cell phones and our computers and so on. There is a growing scarcity of high-grade ore deposits on land, and there are other kinds of conflicts on land use conflicts and social justice concerns. And there are a lot of geopolitical concerns because some of the elements, like cobalt, is mined mainly in one country in Africa, and there are other elements that are mainly mined in China. So there's a lot of security and risk concerns. And this figure shows for the EU critical raw minerals, and some of the ones that have both high supply risk and economic importance include cobalt. Phosphate actually shows up in that white box, and there's a few others. So the argument for deep seabed mining has been made early on as being a much better solution to provide minerals than land mining. The argument has been that people will not be displaced, that there will be no impact on food production, that there will be no impact to freshwater supplies, that there's no significant risk of disaster, and there's no impact on soil formation, erosion, and historical and cultural values. And I would say 2-1, this has turned out not to be true, but this is what everybody believed 10, 20 years ago when people were really all gung-ho and began looking at seabed mining. And I'll talk about, why most of these aren't true, but we've come to understand that there are impacts, and also everything that gets mined in the deep ocean has to be processed on land, and all of that processing creates almost all of those problems, but people tend to forget about that. So I'd like to introduce you to the 3 major ecosystems that are being considered for mining in international waters. The first are the polymetallic nodules that occur on abyssal plains. They are turning out to be one of the most biodiverse habitats on the planet, believe it or not. But most of the species continue to be undescribed. They are covered with nodules that take millions of years to form. They are associated with animals that aren't found anywhere else. Half of the species that live in this ecosystem rely on the nodules for substrate as a place to live. And most of the animals are small. They're not what you see in this in these beautiful videos, which they're very eye-catching. But most of the animals are really tiny. So for those of you who know the size of a penny, that's the size of most of the animals. You can fit all those all those animals in that picture practically on top of 1 penny. So they're really tiny, tiny. And as I said, most of them have yet to be described. So people will use eDNA and other technologies to look at diversity and find that fully almost a third of the sequences don't fit any order we know about. 2/3 don't fit any family we know about, and more than 3/4 don't fit any genus or species we know about. So this is truly undiscovered realms of biodiversity. We also know that things happen really slowly in the polymetallic nodule systems. So there was some test mining that was done in the late 1990s. Not really test mining, I should say that, disturbance experiments where they towed something through the mud and created something like a mining track. And then this site was revisited 20 years later and then 30 years later. And basically what they found is the simulation scars are still sharp. The animal abundances are low and haven't recovered. The carbon stocks and even the microbial activity had not yet recovered after all this time. They were a little better, but still remained depressed. And of course, we know those nodules take literally tens of millions of years to form, so no new nodules had formed. So scientists have begun to do restoration or recovery experiments by putting out artificial nodules. That's what you see in the picture in the lower right. But the reality of it is that they might not get their results for another 20 to 30 years, if you think about the timescales on which things happen. And even then, the data suggests, that things might not have recovered by then. It might be hundreds of years. So even the timescale of experimentation will be slow. I mentioned that there's interest in mining ferromanganese crusts that form on seamounts. And these seamounts are areas of enhanced productivity and biomass. They also are areas of intense fishing pressure, so that mining becomes in conflict with fishing in some cases. They support dense corals and sponges, which are now considered to be potentially important genetic resources and to be biodiversity hotspots, kind of like the Amazon rainforest. The species are very long-lived. Some of the sponges and corals can live for thousands of years. And of course, the crusts themselves also grow very slowly. They form at 1 to 5 millimeters of crust per million years. So not really on human timescales. And then the third type of habitat that people would like to mine are massive sulfides at hydrothermal vents. There are on the order of 300, although there were about 2 or 3 vents discovered just last month. I mean, the number grows every month or every year, so maybe there's 300 to 400 vents known. And most of the high seas deposits at these massive sulfide deposits at hydrothermal vents are already under exploration contract for seabed mining. So they support an amazing array of animals. Some of these animals have thought to provide clues to the evolution of life. 80% of the animals that live at hydrothermal vents only live at hydrothermal vents, and these are actually pretty small patches on the ocean floor. They have truly unusual adaptations and symbioses. The animals often have microbial symbionts that rely on chemical energy. Again, the vents are fueled off sulfur, hydrogen sulfide, and methane and hydrogen that comes out of the vent fluids. I mentioned the patches are very small, and the diversity at any one vent is kind of low, but the novelty is high, and from vent to vent to vent, you find different species, especially in different areas. So those 3 types of ecosystems are being considered for mining. There is a 4th type, marine phosphates I mentioned, which are of interest for fertilizer, harvesting for fertilizer, and they form along continental margins. And there actually have been plans to to lease and extract phosphorites from off Mexico, from off New Zealand, from off Namibia and South Africa. And most of those have been turned down by the country's environmental ministries, with the exception of Namibia, where the licenses have been in litigation for the last 12 years, or 11 or 12 years or so. So there has been no phosphate mining anywhere. And in fact, there has been no exploitation of deep sea minerals anywhere yet. So everything I've talked about is just what people would like to do. It hasn't actually happened. So how can it happen? Well, now I'd like to tell you a little bit about the jurisdiction of seabed mining. It's in international waters. It's governed by the UN Convention on the Law of the Sea, and Part 11 created what's called the area. The area is the international seabed. So outside of 200 kilometers beyond the coast is international waters. Some countries can claim extended continental shelf. So the extended shelf is white. The exclusive economic zones are in blue up there, and the international seabed, or the area, is shown in pink. And it's a big chunk of the ocean. It's like 60% of the ocean, 60% of the ocean floor. And access to the minerals in the international ocean is only through the International Seabed Authority, which is charged to act for the benefit of mankind. And the minerals are the common heritage of mankind, and that means that any benefits from mining them have to accrue to all the people of the world. You, me, everybody, and every country. So the International Seabed Authority was created by the UN under UNCLOS, the UN Convention on Law of the Sea. It came into force in 1994, and it has 168 member states. And it is the only agency that can issue contracts for mining in international waters. Those contracts were issued very slowly for the first 10 years, but since then they've been ramping up very quickly, and I'll show you a map. There's 31 contracts now. But only UNCLOS signatories can apply to mine minerals in international waters. So, for example, the U.S. has not signed and ratified the Law of the Sea, so the United States can't go in and mine these minerals, or shouldn't anyway. Let me go back. So, go back a bit here. Hang on. So the International Seabed Authority is a complex organization. It has a secretariat. It has a council, an assembly, and a legal and technical commission that reviews contracts. And the composition of all those bodies is very carefully organized. The assembly is everybody, all 168 states, but different states rotate on and off the different organizations. And the other thing that's very important is that the ISA, the International Seabed Authority, has conflicting mandates. They are supposed to develop the mineral resources and manage the area as the common heritage of mankind, manage those minerals. But they also are charged under UNCLOS in protecting and preserving the marine environment from the harm of mining, and promoting marine scientific research and coordinating and disseminating the results. So they have a kind of a dual mandate, and many people consider this is like the fox guarding the hen house, because it's the same group of people and the same organizations approving mining contracts that are also in charge of protecting the marine environment. There are no separation of those tasks. So here's the 31 international exploration contracts that are out there now. This map just sort of shows you let's start with the polymetallic crusts are in green. They're mostly in the West Pacific, a little bit off Brazil. The massive sulfides are in red, and they're in the Southwest Indian Ridge and the Mid-Atlantic Ridge. And then the polymetallic nodules, there's a little bit in the West Pacific and near India, but the biggest chunk of polymetallic nodule contracts occurs in what's called the Clarion-Clipperton Zone. So I'm going to zoom in here. This is what the Clarion-Clipperton Zone contracts look like. It's a width, approximately the width of the United States, just to give you some sense of scale. It's very big. And all the countries' contracts are color-coded here, and so you get the sense it's a hodgepodge. But you can see all the countries that have mining exploration contracts. Okay, they're not for exploitation, they're for exploring the resource. Tonga, Germany, Jamaica, it goes on. You can see this big list. The yellow areas are reserve areas, which are supposed to be reserved for the enterprise, which is a mining arm created by UNCLOS. The ISA is supposed to mine on behalf of developing countries. So those areas have been reserved for developing countries. And then the hatched boxes are around the outside, mostly, there's one in the middle now, are the protected areas. And I'll come back to those, but those are no mining areas. But I just wanted to point out to you, these three areas in blue used to be they are the United Kingdom's exploration areas, and they were, the exploration was run by UK Seabed Resources Limited, which was owned by Lockheed Martin, but a Norwegian company just within the last month or two bought out those interests, and so now Loke, or however you pronounce L-O-K-E, that company will be doing the exploration for mining for the United Kingdom, as far as I understand. I thought that might be of interest to this group. I mentioned the mandate for protection of the marine environment. That's Article 145 in UNCLOS. And the states are responsible to adopt measures necessary to ensure effective protection of the marine environment from harmful effects. That includes preventing, reducing, and controlling pollution and other hazards that have the potential to interfere with the ecological balance of the marine environment, and protecting and conserving the natural resources of the area, preventing damage to flora and fauna. And you might read this and sort of wonder how does this mesh with the mandate to mine, which is a pretty destructive process. You know, how do you balance this? And people are still asking this question. And I want to talk a little bit about mining disturbance and its scale. So there are many, many different types of disturbance that will result from deep seabed mining. You can think about land mining, and it's not really all that different. But there's sound, light, vibration, physical removal of substrates, and I'm going to go into each of these a little bit more, but there's creation of plumes and changing substrates and removal of structure and contamination and changes to food web. And the thing is that the scales of these will be really, really large. Just to give you some sense of this, if we look at the contract areas in the Clarion-Clipperton zone for polymetallic nodules, you can look at the largest coal mine here, the area of the largest coal mine in Germany, and 1 year of mining, one contract in the Clarion-Clipperton zone will produce damage, will basically mine an area 2.5 times that size. And 5 years, much larger area. And if people figure that the mining operations have to stay in effect for like 20 to 25 years to even be viable. So we're looking at 20 years of mining, and that's one contract, and that's a big area. And this paper by Emma et al. Tells us a little bit about how big the area is, in terms of European countries, but I thought you might like to know that it's roughly 3.89 times the size of Norway is what could be affected by mining the Clarion-Clipperton zone if all the contracts were to go ahead and mine. It's a big area, and it's really a big volume. The estimated volume of impact is thought to be roughly 3 times the size of the Himalayan mountain range. So these are just big numbers, but to try to put them into perspective. Let's see. So I want to talk a little bit about the environmental impacts of mining, and the reason I refer to harmful effects is that's the legal language in UNCLOS. That's what the ISA is supposed to protect from. This is what needs to be avoided to protect the marine environment in all phases of environmental management, and I've listed some of the different phases here, but I'm not going to go into all of them right now. I think it's important to recognize that mining removes the hard substrate that holds the minerals, so it's going to change the substrate. And it's also going to change the shape of the substrate. So it might level off areas or create pits or create depressions. So it changes the vertical topography and probably the current flow. It will change the texture of the substrate. And all of this affects what animals can live there, probably is expected to cause loss of genetic diversity, species diversity, functional diversity, and even habitat diversity, and homogenize large areas of the sea floor. It will also change the geochemistry of the sediments and of the water. And we know that geochemistry and the bacteria that rely on different chemicals underpin these ecosystems. They form the foundation of the food web, and especially at the hydrothermal systems, the bacteria rely on sulfide and methane and iron and, iron in some of the other systems and hydrogen. And so the geochemistry, we never think of ourselves as needing to be stewards of geochemical conditions. We think of ourselves as stewards of biodiversity, but the reality is that to have that biodiversity, we need to maintain the right kinds of geochemistry. Loss of habitat, of course, will happen with mining. All these three-dimensional structure-forming organisms that you see in this picture, like tube worms and corals, will be removed, basically, if they mine these habitats, and that structure really supports a lot of biodiversity. So that's going to contribute to biodiversity loss. We know that suspended sediment plumes will result, not just from the Clarion-Clipperton zone, but even where you mine hard substrate, a lot of small particles are kicked up into the water. It creates turbidity, which will affect feeding and potentially vision. It also can release metal contaminants into the water, which could be accumulated by the organisms and we know will have toxic effects. A lot of people are doing experiments now with massive sulfide chemical contamination and showing negative effects. I mentioned that some of these animals can live a long time. They grow really slowly. They can mature very slowly. So typical seamount fish, for example, can easily be 100 to 200 years old, like the orange roughy. But many of the corals and sponges can be thousands of years old. And the oldest known deep sea organism is a sponge that's been estimated to be 17 to 18,000 years old. So think about that. Once you take out these organisms, they aren't going to grow back particularly fast. There are other issues. It's been found that a lot of the animals I mentioned, there's a lot of endemicity, so the limited spatial extent and patchy nature and some of these isolated habitats creates endemism that could be and mining could create breaks in this connectivity of these organisms so that they won't necessarily recover quickly and that we might have local extinction. So even if a species doesn't go extinct across its distribution, it might be removed locally. We know the ocean is all interconnected, and that means from bottom to top as well as horizontally. And so many of the impacts that start at the bottom will ultimately affect the water column, but there's also return water that's going to come down. The ore would be processed on the ship, and then the water will be piped back down either into the middle or bottom of the water column. And there will be effects on midwater communities and effects on tuna communities. And there are lots of tuna fishing that goes on over the Clarion-Clipperton zone. But we also know there are animals that migrate. And so I put up the migration maps for leatherback turtles and whale sharks, which all go through and across the Clarion-Clipperton zone area. But, the tuna distributions also, you can see, are up there. And so, but that's just a handful of there are many, many other species that use these ecosystems in 3 dimensions. So it's not just a matter of what happens on the seafloor, and the other thing, people forget that benthic animals actually produce larvae that go up in the water, some all the way to the surface. So, there's many, many different types of interactions that will happen if mining occurs. Many people are asking whether mining will affect the carbon cycle and have an impact on climate. And since we have a big climate meeting here in Bergen, this is an appropriate topic to talk about. There's a lot of carbon buried in the deep ocean, and mostly not in rock, but, well, I shouldn't say that because carbonate has a lot of rock. But the Clarion-Clipperton Zone has low carbon content in the sediments, but it's so vast and it covers such a large area that it is a carbon repository. So there's worry that digging up the seafloor will release that carbon back into the water and ultimately allow it to re-enter the atmosphere. But there's also concern about impacts on the biological processes that sequester carbon. So, for example, the mesopelagic animal migrations up and down every day could be damaged, if those plankton, if they run into sediment plumes or toxic return water with contaminants, there can be damages there. The sound, noise, light, all of those things can alter mesopelagic communities. And again, the migrating animals will probably move their migration, move away from any kind of mining operations. So there's potential, and these big animals, they also hold a lot of carbon and move it horizontally across the oceans, like a whale. A whale holds massive amounts of carbon. There's also processes we're just starting to discover. So there are papers coming out of the Clarion-Clipperton Zone research that show that there's dark carbon fixation down there and project that mining would damage or reduce the amount of carbon fixation that happens in the deep sea. And there's also some oxygen production that goes down there, and people still are trying to understand what's producing it. But those are processes, we're just still discovering them, and yet there's concern that they could be damaged. Cultural heritage. Now, this is not something that most people actually think about with respect to the deep sea or traditional knowledge, but they're starting to. And in fact, the last International Seabed Authority meeting had the first interventions by representatives of indigenous peoples and native peoples. It turns out that culturally, the mid-Atlantic slave trade crossed the area that's actually been leased for, or not leased, but the exploration contract areas for seabed mining on the mid-Atlantic ridge. And that slave trade led to 1.8 million slave deaths in where basically the remains of those people lie at the bottom of the Atlantic. And for many peoples, that's considered a sacred area. But there are also all sorts of indigenous and native peoples that have ancestral connections with the sea. They believe either that their ancestors reside in the deep sea. I know some South African tribes have that. And there are origin myths where people believe their ancestors originated from the deep sea. Many people consider themselves resource custodians of the deep sea, especially many of the small island nations in the Pacific. They rely on aspects of the deep ocean for marine navigation and traditional medicine. So there is a cultural aspect to the deep sea that is only now being considered by the International Seabed Authority. It's not really clear whether any of those people will have a voice in deciding about mining. Environmental management, I want to talk about. So, I've mentioned there is no mining. There are only exploration contracts at present. And it's been stated that the environmental regulations have to be in place before the exploitation contracts can be issued. And I've listed here some of the things that are underway or should be underway, but are not yet in place. And I think really importantly, there are no environmental goals and objectives, overarching ones, that have been designated by the International Seabed Authority yet for mining. And without those, it's very hard to know what you're trying to protect. There have been papers written about the fact that they need these goals and objectives, but we don't have them. Regional environmental management plans are underway for each of the 3 types of resources. They're best developed for polymetallic nodules. The designation of areas of particular environmental, I should say interest, not concern, areas of particular environmental interest, APEIs, are the protected areas that are part of regional environmental management plans. So they're underway for the West Pacific Seamounts, they're underway for the Southwest Indian Ridge and for the Mid-Atlantic Ridge, but there is one developed for the Clarion-Clipperton Zone. And then there's all sorts of contract-specific environmental regulations that have to be made, guidelines for impact assessment, management and monitoring plans, and the contractors are supposed to designate preservation reference zones, areas that they set aside for monitoring communities that have no impact, and they are supposed to compare them to impact reference zones, which are areas they expect to be impacted by mining, for example, through turbidity plumes or so on, so that they can compare natural variability to mining-caused damage. And none of these have been designated yet. So there's a long ways to go in terms of developing environmental management. These are, again, the APEIs. 3 or 4 new ones were just added recently. But you'll notice, for the most part, they surround the mining contract areas. Only one of them sits inside. And there's a lot of concern that these APEIs are not identical in terms of ecosystem attributes to the mining areas that they're supposed to be protecting. So the mining claims, the contract areas have the highest nodule density, and as a result, they have different communities than the APEIs which surround them. And so there is some concern there. I put this slide in because one of my particular interests has been trying to get the International Seabed Authority to build climate change into everything that they're doing, including understanding that climate change is a natural stress and cumulative stressor, and that it can make it harder for ecosystems to recover, but also that they have to realize that climate change won't affect the contract areas in identical ways. And so I've worked with Chu Lin Wei and a host of others to look at the changes in climate parameters, food, oxygen, pH, and temperature, projected into the future. And the main point, these are all the contract areas. And the main thing I want you to see is there's a lot of different colors there indicating that climate change is not going to affect these areas uniformly. Some areas are going to experience more loss of oxygen or decline in pH or rise in temperature than other areas. Some of the APEIs will not be affected the same way, but some of the mining contract areas won't be either. And yet you really, other than them worrying about emissions from the mining ships, you don't see climate entered as part of the baseline data that's supposed to be collected. You don't see climate in environmental monitoring. Climate is going to change these ecosystems over the same time frame as mining would, but we need to be able to distinguish climate impacts and mining impacts. Okay. So one of the things for those of you who do track the mining issues is you will know scientists have been saying that we really don't know enough to be mining. There's a lack of knowledge. Well, Diva Amon said, and the people, that she's worked with set out to quantify this. And so there were a large expert surveys of all the different categories of information, information about connectivity and genetic structure and biodiversity and currents and all sorts of things, what's needed to actually do proper environmental management of mining. And what this paper found, and I'm one of the authors also, was that only 1.1% of the scientific topics assessed across the contract areas had sufficient information to enable evidence-based management of deep seabed mining. So there really is a well-quantified now lack of knowledge. And despite this, test mining has gone on in several places, in the Clarion-Clipperton zone and also within a few countries, which I'll come back to. But what are the kinds of knowledge that we need? that we don't have. And, it's a very long list, but I've sort of tried to summarize it here. We don't know very much about the taxonomy and diversity and the distributions of species. We don't know their life histories, longevity, or reproductive modes. We don't know much about the midwater communities or about inactive vent communities. The southern hemisphere is really poorly studied, and we haven't studied, for the most part, the APIs, which are supposed to be the protected areas. We don't know much about connectivity. We don't know the spatial and temporal variability of the ecosystems and communities in these areas. And we're still discovering new ecosystem functions and services, new biogeochemical processes, so we're really still in a discovery phase. But we also have a lot of applied knowledge gaps. There are unknowns around the nature, severity, implications, and potential mitigation of environmental impacts. Serious harm is a technical term, that has to be avoided by the ISA and under the law, but we don't know what it is. What does constitute serious harm? We don't have good indicators of ecosystem health and threshold values for harmful effects on the environment, another legal term. We don't know how extensive the impacts of mining one area will be on the surrounding areas. We don't know what the impacts are on ecosystem services like fisheries or nutrient recycling or carbon sequestration. We don't know the risk of extinction of individual species. We don't know how quickly different taxa would recover or how quickly community ecosystem functions would recover. We don't even know if restoration or remediation is possible. Many people think it's not possible on human lifetimes. And we don't know much about cumulative impacts, like adding climate change on top of all this. So, the summary is that there's really insufficient scientific knowledge to enable evidence-based decision-making in line with the ISA's environmental obligations. The Emin et al. Paper produced a roadmap, that says what we need to do and projects, over a 10-year timeline that we can get to some of this. Okay, but do we have 10 years? And I'm going to talk now about the current situation for mining. How many of you have heard of the 2-year rule? Oh, I see about 4 or 5 people raise their hand. So this is a weird part of the law of the sea. And what happened is that in June of 2021, the Pacific Island nation of Nauru notified the International Seabed Authority of its intention to invoke this Section 1 of the 1994 implementing agreement, which is called the 2-year rule, and it went into effect in July 2021 on the basis that the mining company under their sponsorship, which is the Nauru Ocean Resources Incorporation, intends to apply for the approval of a plan of work for exploitation under UNCLOS. So this is the first notification that somebody wants to mine commercially. And that gives the ISA 2 years to get all the regulations in place. And that meant that by July 2023, they have to finalize a set of regulations to govern exploitation of the minerals on the seabed, or they have to provisionally approve the mining contract. And, the first year, people said, okay, we're just going to get to work and get the regulations done. But now we're nearing the end of that second year of the 2-year rule, and everybody's terrified that this means that Nauru gets to mine. Just go ahead and mine. And so, so there have been a lot of intercessional meetings, and the ISA held a lot of discussions at their last meeting in March, and they all agreed that provisional approval is not final approval to mine, and it does not constitute an exploitation contract, and that they discussed who's going to actually be able to make the decisions about mining. And there's been a lot of papers even written on whether it's legal for mining to go ahead under this 2-year rule or not. But many states believe, and they voiced these opinions at the last ISA meeting, that the regulations, standards, guidelines, and institutional framework has to be in place before mining should start, and it's not in place. So once this 2-year rule was invoked, it really set off sort of a storm of interest in having a moratorium on deep seabed mining. It wasn't, I mean, there were clearly people who felt we should not be mining long before that, but this is the national status, okay? Some people are calling it a precautionary pause, but starting in June of 2022, 3 island nations came out completely against, well, they wanted to have at least a 10-year moratorium on mining in June. And then July of 2022, you can see a bunch of other countries join them: Chile, Costa Rica, Ecuador, Federated States of Micronesia, and Spain. In October, New Zealand joined them. In November, France, Germany, and Panama. And France is the only country that has come out completely against seabed mining forever. They have said there should be a permanent ban. All these other countries are signing on to a moratorium. You know, in March of 2023, Vanuatu and Dominican Republic came out against mining. So the problem is, you know, if you count up the countries, it's really a small fraction of the 168 that belong to the International Seabed Authority. So these countries alone are not going to stop seabed mining. There have, I should mention that marine scientists, 704 of them, have signed a statement calling for a pause to seabed mining while more information is collected. And a whole bunch of countries have come out in favor, companies have come out in favor of a moratorium. You can read the list up here. There are car companies who have said they will not source deep sea minerals in making their product. Well, car companies and even Microsoft and jewelry companies, you know, who said they won't source deep sea minerals in making products. And then some car companies said they won't use deep sea minerals in their electric car batteries, which use a lot of cobalt and lithium right now, although that technology is changing rapidly. So there's a movement, but I would say that, you know, the UN and the ISA has a lot of momentum behind it, and they're slowly working on making regulations. And these are the things they still haven't finalized. So they have to have the financial terms set and royalties. And now they've begun, at the pressure of some states and environmental groups and science networks, to consider internalizing the environmental costs of seabed mining in the royalty regime. And they're looking into ecosystem services valuation of deep sea, of the targeted ecosystems. As I mentioned, they haven't developed the protection and preservation of the marine environment. Requires these impact reference zones and preservation reference zones, and they don't have those. There are rules on inspection, compliance, and enforcement that aren't made yet. There's a lot of concern about what happens if you put an inspector on a mining ship. How safe and independent will those people be? Will they be harassed? We have a lot of experience from fisheries observers not being all that safe. So there's questions there. They have to develop closure plans. And, you know, they're still trying to figure out, can they even restore these habitats? Should it be required? A lot of countries have their exploration contracts expiring, and there's question about what to do with those. Do they roll over into exploitation or renew? So we have a lot of renewal of exploration contracts right now. There's lots of other marine users who need to be engaged, especially the adjacent countries and island nations that have waters near the mining operation, potential mining operations. They've been discussing environmental compensation funds and sustainability funds, and you know, they always say nothing is agreed until everything's agreed. And there's a lot of disagreement. If you listen to the ISA, you know, discussions, which are actually streamed live for the public, many of them, so you can hear these. I feel they're very far away from having a functional mining code. But there's a lot of questions being raised as well, like how can the same agency that approves mining contracts be responsible for protection of the marine environment? It's the same country sitting on the contract approval that have to do the protection. There are also questions about who's going to benefit from deep sea mining, and does this meet the intent of the common heritage designation of these minerals? because most of the countries, even the small island nations that have contracts, the companies that are running these contracts are multinational conglomerates based in the Northern Hemisphere, based in wealthy countries. And so it's clear that right now most of the money is going to flow to wealthy Northern Hemisphere nations. That's a big concern. And that was not the intent of the Common Heritage designation. And so that's the question, where is the enterprise? The enterprise is supposed to mine on behalf of developing countries, but it hasn't even been set up yet. The ISA just put it off and put it off. They have a temporary acting director general, but there is no enterprise. So, as with many other things, it looks like the developing nations of the world might get left out of this. And there's also a provision in UNCLOS that the countries that mine these minerals on land are supposed to be compensated for any economic losses when the market gets flooded with deep sea minerals. And that hasn't been worked out yet either. So this is the international scenario, but I just wanted to mention that there is the potential for deep seabed mining to occur in national waters. And apparently LOCA is the one that is pursuing this for Norway. But the Cook Islands also has contracts. I believe they have let licenses for exploitation mining or maybe just exploration at this stage. Japan has done test mining on its massive sulfides at hydrothermal vents. Brazil is interested in mining cobalt-rich crusts on the Rio Grande Rise, which they've now claimed as extended continental shelf. Namibia has, as I said, in litigation, exploitation contracts for phosphorites. New Zealand, Tonga, and there's a whole bunch of other countries that have hydrothermal vents with massive sulfides and have exploration contracts let. So we don't know what's going to happen with all these other countries. They may be the first to mine before international waters, but it looks like Nauru intends to ask for an exploitation contract this year, sometime later this year from the ISA. So we'll see what happens with it and their impact assessment and so on. Okay, so I'm just about done here. I have just a couple more slides. I want to say that beyond the ISA, which is a weird little, it's an unusual UN organization, is in that it's quite independent, but there needs to be interaction with the other UN organizations that manage and govern resources and biodiversity in the ocean. And that includes this newly agreed upon Biodiversity and Sustainable Use Treaty. It's called the BBNJ Treaty, which governs marine genetic resources and protected areas and impact assessment, capacity development. It's really promoting data transparency, and we really hope the ISA would work with them. The London Convention governs dumping into the ocean, and it sure looks like mining is going to involve some dumping of stuff back into the ocean. And the problem is it came from the ocean, so it's not so clear who regulates it. There needs to be work with the Convention on Biological Diversity over protecting biodiversity, work with the UNFCCC on climate protection, work with the fisheries organizations, the RFMOs and the FAO, and the Regional Seas Organization to make sure that mining doesn't really damage fisheries resources. And so, the ISA is going to need to interact with all these other agencies. And also, we need to think about, many of you, I'm sure, are familiar with Sustainable Development Goals, teaching courses here on the subject. And, those goals are about protecting ecosystem integrity, protecting from pollution, protecting from acidification, and so on. And we need to make sure that mining activities don't work against those sustainable development goals. And I just want to introduce very briefly, how do we bring science to the policy making in the mining world? And the Deep Ocean Stewardship Initiative, which is an organization that I co-lead, has a mission of integrating science, technology, policy, law, and economics to advise on ecosystem-based management of resource use in the deep ocean. And it has a minerals working group that's been very, very active on this front. It's not an NGO. Its goal is to bring science to the policymakers, and as such, the DOSI members attend the ISA meetings, make interventions, critique the regulations, write policy briefs and white papers. And here's some of the policy briefs that have been prepared just for the ISA delegates, on relating to seabed mining. You can see that it covers everything from biodiversity and climate change and traditional knowledge and connectivity. There's a lot of topics there. They're all available at the DOSI website if anybody's interested in looking at these. And let me just go back, and the DOSI website is simply dosi-project.org. And anybody can join. You can join the Minerals Working Group. This group has developed some pretty good relationships with delegates at the ISA and can actually be a voice of science, help answer questions. They lead side events. So, there is a direct way that deep sea scientists can bring their knowledge to the policymakers, because most of the policymakers are not scientists. They're law and policy experts or political science experts. So, my final message is we really are in a place, mining is potentially very close to happening, commercial exploitative mining. But I believe we need to be proceeding with caution. There's a lot of issues, many more than I had time to talk about today even. But I hope I've given you all some things to think about. And so I'd like to thank you for listening. Sorry, I went on a long time.
Thank you, Lisa, for a fantastic presentation. I'm impressed how much you managed to put into.
I think I went on too long, but
this time, but also taking us down to these fantastic, fascinating ecosystem that was thought to be the marine desert only 20, 30 years ago. So, and also showing us all these different ecosystems there, but also the policy around this. So you were, of course, talking a lot about the ISA, but there was a new law coming for the high seas, and many of these deep sea vent systems are in international waters. Do you have any reflections, and do you think it will be better after the BBNJ negotiation managed to?
No. And the reason is that I attended that last meeting of the BBNJ, and the states made sure that there is language that the BBNJ cannot supersede the jurisdiction of any existing UN body, which means the ISA jurisdiction remains intact, and the BBNJ and any of the activities of the BBNJ, in many ways, don't include mining. Same with fishing. There are already bodies that regulate fishing in international waters, and so the BBNJ agreed upon language pretty much excludes fishing. So, it can cover what's left. Marine genetic resources, maybe cable laying, maybe climate interventions. We'll have to see, what other kinds of activities. Now, the idea is that they would work with the ISA and with the FAO, but this is going to be a real challenge. I think it's one of the, I'm a scientist, not a policy expert. I see it as being a challenge ahead.
So you still think it's far away to go on that?
Yeah, but people don't realize that BBNJ is not going to protect against mining or fishing. It's going to cover everything else.
Yeah. Okay. So then I think we'll open up some questions from the audience. Yes?
Thanks for the great talk. I was wondering if you could explain a little bit more, what does these exploration licenses actually mean? Like what does what are they doing right now down there with these, having this exploration license? And do you think that, deep sea mining, you displayed very nicely all the negative effects that it will have, but do you think this push has also increased our knowledge on the deep sea?
It definitely has increased knowledge of the areas that are targeted for mining, no question. We know more about the Clarion-Clipperton Zone than any other abyssal plain polymetallic nodule-covered area for sure. And so the exploration contracts, I believe they're 15 years long, and they require baseline data collection. So companies, well, no companies can have a contract, only states, right? But the companies work for the states, and they go out there and they take samples, sometimes every year or every other year. They describe the biodiversity of the area. They look at the mineral resource and its ore grade and things like that, and they measure currents and describe the ecosystem. And that's exploration. However, the first test mine has already been done by Nauru, and they used the exploration guidelines rather than the exploitation guidelines, which don't fully exist yet, in preparing their impact assessment. And that's scary because they hauled up, I don't know how many tons of nodules in their test mining. And it was done as if it was exploration, which many people have questioned.
Yeah. Yes, thank you. I have two questions. One is maybe a little more of a note. You mentioned Lockheed Martin and also this company Loke, which I just looked up and which is partnered with the Kongsberg Gruppen, which is a Norwegian arms conglomerate. Is this normal for major defense contractors to be this involved in resource extraction? Do you know? This is the first thing. Also, the second thing would be, is there sort of a specific policy point you would like to emphasize for us as academics in Norway at the moment in this audience?
So is that normal? Well, Lockheed Martin was exploring nodules in the United States about 30 or 40 years ago, before the law of the sea went into force. So it continued doing so by opening a subsidiary in the UK, which signed for law of the sea. Did you say Loke was also defense related?
It's sponsored by Kongsberg. There's some.
Yeah.
I don't know how people.
So I don't know how normal it is. You know, some countries have mining companies that have emerged from dredging companies, and other countries have mining companies that are part of the government, like China. And I don't know if they're also related to the defense industries or not. In terms of a policy message, you're asking what is my policy message? I mean, everybody has to decide for themselves how they feel about deep seabed mining. You know, I personally feel that we don't have enough information. And I don't know if we will have enough information to feel that it's possible to do deep seabed mining without doing harm to the environment that we're not willing to in a relatively pristine ecosystems, you know. But in policy-wise, I guess I feel like the biggest need is how do we take this heavily siloed international ocean with different bodies managing fish and different bodies managing genetic resources and different bodies managing minerals, and how do we start managing the whole ocean for the benefit of humanity? And that's our challenge. I don't know. I don't have the answer, but I know a lot of people are looking for those answers. Yeah.
Yeah, thank you for the talk. It was really informative. And I think my question goes a little bit to what you just said. So I'm wondering about the quantity or amount of globally of deep sea mining. So basically the companies obviously are interested to exploit as much as possible for profit. But is there anyone estimating, or is ISA maybe supposed to be responsible to make some estimates of, for the global sake, what amount of deep sea mining would be necessary for a positive development of a global society? Basically, these really big questions. Is there someone trying to figure out if we exploit 5% of the deep sea, that would give us enough minerals for 20 years forward development globally or something like that?
Well, I mean, the current debate I didn't actually spend any time on in this talk. Those estimates have been made. And the way it looks is, in terms of hydrothermal vents, the resource is so small in the ocean compared to what's on land, it doesn't make sense to even mine there. In seamounts, I'm less clear. it's awfully destructive. In the Clarion-Clipperton zone, which many people believe will be the first area to mine in the polymetallic nodules, there's really large amounts of cobalt and nickel there that are more than, what's readily available on land. And so people are very interested in getting that. But there's a big debate about whether we need it, and partly because battery technology is changing very fast. So is the recycling, reuse, and redesign technology. Many of you may have seen, Apple's got new machines that extract, I think it's either Apple or Microsoft, probably Apple, that extract their minerals from all reused cell phones, and they vowed to not use new minerals, and the technology for all of this is changing so quickly. We have the minerals we need for the next 10 years, and so the question is, if you commit to mining now, you're going to be mining for 20 years or maybe 30 years, but will we have a technology that's just gone past that, so that it's not necessary? Also, I've learned a lot from the land mining people that land mining has gotten much less destructive. They can get new mines underground, without displacing people, without as much environmental damage. There's new social codes of conduct for mining, and there's new ways of getting minerals out of lower grade ore. All the technology changes so fast. So many people have questioned, do we need to go into one of our last pristine ecosystems to get these minerals? And, what's going to happen? I don't think we know 10 years from now if we're still going to need them.
Hi, Lisa. Thanks for a really nice talk and for introducing us to the term stewards of geochemistry. I like that phrase. This is kind of a related question. Given that none of the major land-based mining companies are really buying into this, and in fact some have pulled out, so Anglo American pulled out of Nautilus Minerals in Papua New Guinea, do you read that, like I do, as a sign that there's a huge amount of skepticism in the traditional economic geology industry about this in terms of profitability? That was Anglo's reason for pulling out. They said they wanted to focus on more sure deposits or larger deposits. Like you said, the vents are small.
I think that's probably right. I don't really have the expertise to say that, but there is growing skepticism across the board, and you saw all those companies that I put up that are, and that number is just going to grow, new ones every month. And so I think profitability is a big question, and the prices of these metals is very volatile. So the question is, will we see, you have to realize Nauru is the mining by Nauru is going to take place by the metals company. And the metals company used to be Nautilus Minerals, but they went bankrupt. They left Papua New Guinea with a really big bill.
Aren't they going bankrupt again?
And they might be going bankrupt again. But apparently they've got some new infusion of money that just happened last month, So it's a kind of a uncertain industry, for sure. But the ISA is going ahead as if it's going to happen. And most of the countries that are engaged see big dollar signs. That's why they're doing it. They're not doing it as much, I don't think, to save the world with electric car batteries. I think they're doing it because they see it as a source of income.
Okay, I don't see any more hands.
Since it's passing me, I also have a question then. Thanks for a really nice talk. So one question I was wondering, there's this call for the 10-year moratorium or pause or whatever you like to call it. Two things. Do you think that's the best option, or would it be better to have good regulation in place beforehand? And related to that, do you think, or are you concerned that we, after 10 years, is still faced with a knowledge gap that's not closed, and then they say, okay, you had your 10 year, but you didn't make it. Sorry, now we start mining.
Well, It's not one or the other. Even if there's a moratorium, science will continue and the regulations would continue. But the moratorium will only happen if the ISA itself, which are those 168 member states, decide they're going to have one. And to me, it doesn't look like that's what's happening right now. You know, those countries I showed, I forget how many there are, maybe 15 or so. That's not going to stop anything. So the regulations will be developed. The question is, you know, will they be developed by the time the metals company starts mining, or GSR starts mining, or one of these other, you know, that's a Belgium company. You know, there are other companies out there that are hoping to mine in the next few years.
Okay, then I see no more hands, and then I will just thank you so much for this very nice presentation. I think there is a lot of, we have been presented with a lot of facts and reflections, but I think this is highly actual topic that we're discussing, and I think you will gonna hear a lot of this discussion in the future and in the time to come now. So thanks for giving the background for this. I know there is quite a few of the people in the audience that is going to another event where we're talking about more food from the ocean, which is also kind of an important topic. Usually we have gift from university as an umbrella, but we don't have any more left because we have had very bad weather lately. And I would love to give you some food from the ocean, but we didn't have something that you can bring. But we have some food from Bergen. This is honey from bees from the top of the Grieg Hall, concert hall in Bergen. So a little sweet from us. Thank you so much for giving the lecture, and thank you for coming.
Thank you. Thanks, everybody.